equations. The purpose of doing this is that you have two equations of straight lines, and those two straight lines would intersect at a point, and you're trying to find that point. Okay. So the three methods that you can use are written down here for you. Maya? Method number one is graphical method. You could draw up a graph of those two straight lines and try to physically read off the graph where they intersect. The problem with that method is, first of all, your graph would have to be pretty accurate in order to make sure that you're reading off the right point. And secondly, unless the numbers come out as whole numbers, it's really hard to read accurately off the graph something like 4.2 or 4.149, whatever it is. Okay, so it's not a very accurate way of doing it. So we don't spend a lot of time learning about the graphical method. We prefer to focus on the algebraic methods, and there's two of those. The first algebraic method is the substitution method, which is the one we're going to be learning about today, where you want to sub one equation into the other. That's why it's called substitution. Then we're also going to learn the elimination method, which is where you want to eliminate either the x or the y from the equation to help you solve it. So it says there, this exercise, we will focus on the substitution method. This is an algebraic method. There is no need to draw the graph. As the name suggests, it is where one equation is substituted into the other. It is always useful, it says in here, to have one equation in the form where one variable is the subject. So that means either the x or the y is by itself, like in this equation here, the y is by itself. If one letter is by itself, then that's in the right form to sub it into the other one. Okay, so example time. Example 1. Is the point 2, 4 the point of intersection of 3x minus y equals 2 and x plus 2y equals 10? Now, we could use the substitution method. I'm going to use that for all the rest of the questions. For this question, because I've given you a point, there is another option. You could substitute that point into the equations and see if both of those lines go through that point. All right, and we did that in one of our last exercises, but it was just only one line that we had to test. This time we have to test both of them. Okay, so let me show you how to do that. In this first line here, I'm going to substitute in when x is equal to 2. Okay, that's coming from this point here. I had the point 2, 4. I'm subbing in the x value, the 2. I will get 3x becomes 3 times 2 minus y equals 2. And I'm going to solve that to find the y. So 3 times 2 is 6 minus y equals 2. Subtracting the 6, I get negative y equals minus 4. And dividing the minus from both sides gives me y equals a positive 4. Okay, so far that one works because I got the y value, which was 4. That line works. Let's make sure, because both of the lines have to go through that point for them to intersect there. So let's test the second one. So now into this line, I'm going to do the same thing. I'm going to sub in when x is equal to 2. So that will be 2 plus 2y equals 10. And solving for the y. Subtracting 2, I get 2y equals 8. Divide by 2, I get y is equal to 4. So both of them, when I sub in 2, I get y is equal to 4. I was just confused about what the question was. Which means yes, both of those lines are going to intersect at that point 2, 4. Charlie?
So if both of them equal the same
if both of them
y is in the point, then
yes,
it's right.
Correct. Now, to be honest, you're not going to use this very often because it's very rare that I actually tell you what the point of intersection is. Most of the time, I'm going to be wanting you to find it. Yes, Ruby?
Yeah, why do you do x equals 2 and not y equals 4?
What I'm doing, well, you actually could. If you wanted to, you could start with y is equal to 4 and show that both of them get x equals 2.
Oh, you just have to do
You
x
could,
for both of them.
that's right. You just want to show that both of them, you sub in one thing and you get the same result from both of them.
But then does that mean you have to do x and try, y now?
No. Done. I've shown that when x equals 2 for both of them, I get y equals 4 for both of them. Yeah? Alright. Question 2. This is the more typical type of question. This is what you're going to practice over and over and over. We want to use the substitution method to find that point of intersection. So, remember that you always want to have either the x or the y by itself in at least one of the equations. I actually have it in both of them. Okay, I've got y equals x plus 5 and I have y equals 7 minus x. So what I'm going to do, and you probably remember this from last year, I'm going to number these equations. This one here is going to be equation 1, and this one here I'm going to call equation 2. I do that so that I can explain to the person who is trying to follow your working out, which is usually me in your test, the process that what you're going to do to solve these. And what we're going to do is we're going to substitute, so we say sub for short. I'm going to sub equation 1 into equation 2. Now that means in equation 1, I have y is equal to the x plus 5. So I'm circling that. That x plus 5 is going to replace the y in the second equation. I'm subbing it in there because that's what y is equal to. Y is equal to x plus 5, so I'm putting x plus 5 where the y is in the second equation. That will give me, following that second equation, the y is x plus 5 equals 7 minus x. Now by doing that, there is no longer any y's in that equation and I can solve to find out what x is. So I have x on both sides. I'm going to move the smaller one. The minus x, the opposite is to plus x, which will become 2x plus 5 equals 7. The little instructions you would write would be to plus x like that to get rid of that one. Then I have two numbers to get away from that x. So first of all, I'm going to subtract the 5. 2x equals 7, take away 5 is 2. And the last step is to divide by 2, which means x is equal to 1. Now, we are after a point of intersection, which is I think what you were thinking before, where you need an x value and you need a y value. I've found the x value. I now have to sub that back into one of the original equations. It doesn't matter which one. You should get the same result either way to find the y value. So I'm going to sub into, I'm going to do equation 1. So if I put x equals 1 into equation 1, I get y equals, the x is 1, then I have a plus 5, which means that y is equal to 6. I now have an x value and a y value. We are done. However, we just like to write our solution as a point because it is a point of intersection. X value first, y value second, close the bracket. Yeah? Remember doing that last year? Let's practice some more. Yep.
I don't get what you mean when you, because I don't do it that way. I don't know what you mean when you like sub 1 into 2. Like what?
So that was the orange stuff that I've written on there.
Yeah, I don't know.
So this is equation 1. I have y equals that.
Yeah.
So this is going to be the y in that equation. I'm replacing the y with the x plus 5. So that y is x plus 5. And then I have the 7 minus x from the rest of that equation. All right, we're going to practice it again. Practice it a few more times. Question B. Now again, both of those equations there have y by themselves. So let's number them like I did before. Equation 1 and equation 2. I'm going to do the same thing because they're both y equals. I'm going to sub equation 1 into equation 2. Now that is y equals 8x minus 5, that's the y, and it's going to go into the second equation where the y is. It replaces the y. So let's write that down. The y is 8x minus 5, and that's equal to 5x plus 13 over 6. All right, does that part make sense?
Yeah.
Okay, good, because now we just want to solve for the x. We don't like fractions in our equation, so the first thing I would do is times the 6 across to the other side. That will be both the 8x and the minus 5. So if you're doing all the steps, you need to put that in brackets. Some of you, I know, would be tempted to expand that out straight away, and that's all right, as long as you remember to multiply both of them by 6. So that will be 6 8s are 48, x, and 6 times 5 is take away 30, equals 5x plus 13. Now we have pronumerals on both sides. So let's subtract the 5x, the smaller one. 48 take away 5 means 43x, take away 30 equals 13. And we keep moving things away from the x. Next, plus the 30. 43x equals 43. And last step, divide by 43. So it really does need you to be confident solving equations, okay? Because once you do that substitution in, it's all solving the equation, getting that x by itself. Once you have the x value, remember to sub it back in to find the y value. So I'm going to let's sub into equation 2 this time, because that will give me the y by itself straight away. So y equals 5 times 1 plus 13 over 6. You could type that in your calculator. That's 5 plus 13 is 18 over 6 gives you 3.
Is it 5 plus or 5 times?
It's 5 times 1, which is 5, and then it's 5 plus 13, which is 18. So the solution, remember to write it as a coordinate, please. The x value was 1 and the y value was 3. All right, another one. One more. Yes.
How did you get 3 out of that whole thing?
I calculated this fraction. So you can either type that whole thing in your calculator if you want to, but I did that in my head. So I went 5 times 1 is 5, plus 13 is 18, so the whole top is 18, and 18 divided by 6 is 3. All right, one more. Still want to use the substitution method, but when you look at these equations, remember the key thing is you need to have either x or y by itself to use the substitution method, and I don't currently have that. Oh, I do. No, I do. I thought I didn't. I do. The second one. This one I don't have it, but that one does have x by itself, so it's not as hard. I have to find another harder one that you have to rearrange. We do have it. So this is equation 1, and this is equation 2. The one that has the letter by itself, the second equation, that's the one that you have to sub in. So I'm going to have to sub equation 2 into equation 1. Because I've got x by itself, I'm going to be taking that, because that's what x is equal to, and I'm going to sub that into that equation where the x is. So following through equation 1, you get 7y minus 2, but not x. The x is going to become the 3y minus 2, close bracket, and that's equal to 8. So what I've written down there is exactly the same as equation 1, it's just replacing the x with that 3y minus 2. Now I need to solve and find out what that y is. So here comes the equation solving part. Expand the brackets, collect it all up, and move everything away from the y. So let's do that. 7y, expanding the minus 2. Minus 2 times 3 is minus 6y. Minus 2 times minus 2 makes a plus 4. Now I have two y terms right next to each other, so I'm going to collect them as like terms. 7 take away 6 is 1y, or just y, plus 4 equals 8. And subtract the 4 to get y equals 4. I have the y value first this time. I still need to find the x. So I'm going to sub back in. Where do you think I should sub? All right, subbing into equation 2. I will get x equals 3y becomes 3 times 4 because y is 4 minus 2. 3 times 4 is 12. Take away 2 means that x is equal to 10. So we write our solution as a point. So x is 10, y is 4. And that is how you do substitution method.